Welcome to Decode It, a podcast series helping understand more about computer technologies and its beginnings. I'm Ashley Griffin, involved in IT from the 1980s, first with the Atari ST, then on to computer networks in the early 1990s. Today's episode is about the DHCP server, so Dynamic Host Configuration Protocol. Its goal is to give out IP addresses and other client-related information, such as gateways, subnets, and names. The client or appliance would broadcast out for any server listening on port UDP 67. The client would be then receiving that data on UDP port 68. The DHCP server came around in October 1993. Previously to the DHCP server, there was RARP, which is Reverse Address Resolution Protocol, and that was in 1984. That was then replaced with BootP, which is Bootstrap Protocol, and that was in September 1985. BootP only runs in IP version 4, so that's the 0.0.0.0 format of IP addresses. BootP also was able to relay requests serving multiple subnets, and a subnet would be the IP address, and the subnet after that is 255.255.255.0 or a derivative of that. DHCP replaced BootP in October 1993. It had enhanced it. It was based on BootP, but it can also reclaim IP addresses, assign other network resources, and was more detailed with that. So router, which is the gateway, the DNS server, you obviously had the IP address and the subnet, and other items like the machine name. It also added things like lease time to IP addresses and was further ratified in 1997 with updates such as DHCP info command layer. Generally, the DHCP server will respond to a broadcast, so you normally only have one DHCP server on each LAN segment, otherwise they're all going to respond and you'll end up with clashes with IP address and reclaiming and what it's giving out. There are a few DHCP servers. Microsoft Windows Server has them that you can add in, and that's also compatible with BootP. It will actually do both. Simple DNS has a DHCP server as a plugin, and also Pi-hole, I believe, has a DHCP server. Both of those software we mentioned in the DNS podcast. All firewalls generally have a DHCP server built in, so your ISP, when they supply you a modem, which is also a firewall generally speaking, that will have a DHCP server, but it's very basic. It will give out an IP address, a subnet, a gateway, and a DNS, and you generally don't have the ability of having options into that. That's only usually for full DHCP servers. We normally sell WatchGuard firewalls, and they have a DHCP server that you can assign on each physical copper connection layer, and those you can add options into it manually, which is fairly decent, and that's one of the reasons why we like selling them, as long as you also get VPN and a mobile VPN and endpoint VPN as well to link up two sites together. Now, the options of DHCP, so like option 3 is the router or the gateway, option 6 is the DNS server, option 15 is the domain name. So if you're running a Microsoft Active Directory domain, that would be the option that it uses to send out the domain name for the machine when it asks for an IP address. Option 44 is the Win server, so that's the Windows Internet Naming Service. We mentioned that in the DNS podcast. Options 66 and 67. So 66 is TFTP server. That's the trivial file transfer protocol. And option 67 is the boot file name. So that would be something like /boot.bin. Those two generally go together, and they were used a lot many years ago for hardware like the green streams and the terminals that did not have a program in them. So when you turn them on, they did nothing. the DHCP server would have sent out an IP address with option 66, and then with option 67 those devices knew where to go and get the program, because it knew the TFTP server, and it would know what file to download from that TFTP server. So you could set different areas in a company, like accounting could have one type of terminal, and the sales guys could have another terminal, and you could designate that from MAC address when they ask for the IP address from the DHCP server. So you could assign different option 67s depending on which physical machine was asking for that IP address. A lot of the bars like Starbucks, McDonald's, Tim Hortons, they all run a DHCP server when you connect to their Wi-Fi with your mobile device, whether it's an Apple iPhone or an iPad or an iOS device or an Android. That's generally how they're getting their IP addresses. This is not to be confused with PPPoE and PPPoA. Those are protocols usually for WAN, so wide area network, and you would get them in the older modems. So Bell would be PPPoE, and that would be point-to-point over Ethernet. BT and other phone companies in Europe, that would be PPPoA, so that would be point-to-point over ATM. They do receive an IP address, a gateway, and a subnet, and usually DNS servers maybe, but they're not assigned via DHCP. The protocol is wrapped up in the PPPoE request itself. It looks similar, but it actually isn't. So DHCP was started in 1984, changed to Boot P in 1985, then was called DHCP in 1993, was further ratified in 1997, and is still in use now. I have a lot of sites. Most sites will use DHCP if I'm doing migrations. The issue of having two DHCP servers on one site can cause an issue when you're migrating. If a site's going from an old modem over to a server, then I have to mirror all the data over to that server and then disable the DHCP server on the firewall before I turn on the server. Otherwise, the Windows server, when it turns on, the DHCP service checks to see if there's another DHCP server on the LAN, and if there is, it deactivates itself. So it can be a bit of a pain in the neck. It's just something you have to watch for when you're doing migrations. So the DHCP server, it's old, it's still in use, its current technology hasn't really changed much. Thank you for spending some time with me. Subscribe to see more in the Decode It series.